Student friends, let us begin with paper number 16 for semester 6, namely Modern Communication Systems. And welcome to the first topic to be studied in this particular paper. And the topic is optical fiber communication. Friends, look at here. So this is what we can call it as. It is the optical fiber communication. As the name of the topic itself suggests that there is a communication of the signal from transmitter towards the receiver, but it is to be taking place with the help of channel or media called as the optical fiber. This means that the signal communication that takes place through the fiber optic cable is known as optical fiber communication. Friends, please do remember that. By using optical fiber as a media, by using optical fiber as a channel, one can communicate the signal from one point towards the another point. So optical fiber means it is a small thread-like channel through which the light radiations are traveling. By using a peculiar principle to carry the signal from transmitter towards the receiver, that particular fiber that carries the signal in the form of light radiation is known as optical fiber. And signal communication with that particular fiber is known as optical fiber communication. Friends, please do remember that to understand optical fiber communication, we are badly in need of two things. One is we are in need of light, and second one is we are in need of fiber. Both the aspects we are going to study in the forthcoming lectures. By knowing the plan of our further lectures, how we are going to travel to complete this particular topic, and that's what we can call it as. It is the lecture plan, which is associated with the topic number 1, that is optical fiber communication. In this particular topic, as per as your syllabus, we are going to study need of light. Just I have told you that light radiations are essentially needed to carry the signal through the fiber. Why there is a need of light, that we are going to study at the beginning. Then we are going to study the working principle of optical fiber. If suppose light is there, then what happens inside the fiber? Which principle does it obeys to carry the signal in the form of light? That we are going to study. After that, we are going to study or introduce the applications of the optical fiber, where optical fiber communication is being used. Then we are going to study some basic definitions associated for the optical fiber communication. After that, actually we are introducing the block diagram of optical communication system, what exactly it is. Then we are going to study the blocks which are involved in that in detail, including sources of optical fiber and its types, detectors. All these are the elements which are involved in the block diagram of optical fiber. Its details we are going to study. Friends, after that we are going to study if suppose two or more optical fibers are going to be connected with each other and how those are going to be gets connected. So that is known as the splicing technique. At last we are going to study optical fiber transmitter and also optical fiber receiver. We are going to complete this particular topic after studying the fiber optic digital data communication. Means how digital data can be communicated from transmitter to the receiver by using the optical fiber. Dear students, please do remember we are going to proceed with this particular lecture plan so as to complete our topic. Let us proceed further just to study need of light. As I already told you that without light no optical fiber communication it is possible. Dear students, please do remember that light radiations are essentially used for optical fiber communication. You are all well aware that you have been studying the light radiations since from 10th standards. And you are aware that light is electromagnetic radiation. Light is electromagnetic wave. Light possesses almost all the properties which are associated with the electromagnetic radiations or electromagnetic waves. So what are the properties which are associated with the electromagnetic radiations? The properties are a reflection, a refraction, deviation, dispersion, scattering, polarization. All these properties are associated with the need of the light. So these properties are being used to carry the signal in the optical fiber communication, and that's why light is needed. Once again, please remember, light has a high frequency short wavelength with IR visible and ultraviolet mode. Means light radiations are available in ultraviolet radiations, in visible radiations which we can visualize, and also in invisible radiations as IR. Light has a high intensity and can be modulated. Dear students, in the last semester we have studied the process of modulation. If the modulation process is adapted, then signal can be transmitted for a long distance. So that property is also available with the light radiations. It produces high bit rate, baud rate. It has a required bandwidth. It has a better channel capacity. So all these properties are get associated with the light radiations. The definitions of bit rate, baud rate, bandwidth and channel capacity we are going to study in forthcoming aspects. Dear students, these characteristics associated with the light radiations are produced from small size light sources and also can be detected by the detector which are totally compatible for the optical fiber with small size and low loss, high performance and full safety secured electromagnetic immunity of the fiber communication. Means sources of the light, detectors of the light are well associated with the size of optical fiber. The performance of optical fiber is totally safety within the electromagnetic immunity. The fiber possesses light weight also. Weight of the optical fiber is also very less. It is light in weight. All these properties which are being associated with the light radiations are quite adequated with the optical fiber, and that's why light radiations are needed to carry the signal within the optical fiber from transmitter towards the receiver. Dear students, this is why there is a need of light to undergo the optical fiber communication. Why light is needed? Because light is electromagnetic radiation, it has a high speed, it has a high intensity, it has a high frequency, it has a short wavelength, it undergoes almost all the electromagnetic waves properties, like reflection, refraction, polarization, scattering, dispersion, deviation. They have proper bandwidth, channel capacity, bit rate, baud rate, small size sources, small size detectors. All those aspects are possible if we make use of light radiations essentially to undergo through the optical fiber communication. So that's why the light is needed to undergo the optical fiber communication. Dear students, let us proceed further to understand the working principle of the optical fiber. Dear students, prior to start with the working principle of the optical fiber, let us understand the definition of optical fiber. Optical fiber is a cylindrical dielectrical waveguide. Optical fiber has a cylindrical shape. It is made up of dielectric material and it is used to guide the light radiations in the form of wave. So that is the reason why it is called as optical fiber is a cylindrical dielectric waveguide which is operating with the optical frequency. Means it is going to be operated on the frequency of the light radiations. These light radiations are confined within the optical fiber and guiding parallel to its axis of the optical fiber. Such a cylindrical shape waveguide is known as optical fiber. Dear students, I remember this is the definition of optical fiber. Once again I will repeat, optical fiber is a cylindrical dielectric waveguide operating with the frequency of the light radiations which are confined within the optical fiber and which are guiding parallel to the axis of the fiber or along the axis of the fiber. But taking the due advantage of this definition of optical fiber, we can say that this guiding to the light radiation along the axis or parallel to the axis of the optical fiber is possible because of the composition of the optical fiber. The optical fiber has two layers. One is a core and second one is cladding. Thus we can say optical fiber communication is possible due to its composition that contains the core having the refractive index more than that of cladding that surrounds the cores. The core is inner part of the optical fiber, cladding is the part which surrounds the core. But while composing the core and cladding, the care is to be taken that the refractive index of cladding is less than that of refractive index of core. Conversely, we can say the refractive index of core is more than that of the refractive index of cladding. Due to this, what happens? Due to this, light radiation reflects internally. As a being, the refractive index of core is more than that of refractive index of cladding, the light internally reflects. This light propagates within the optical fiber due to total internal reflection in spite of scattering, dispersion, deviation, attenuation and such other losses. We studied that light radiations are undergo burst due to dispersion, deviation, attenuation. In spite of that, due to total internal reflection phenomena within the optical fiber, why total internal reflection? Because the refractive index of core is more than that of cladding. Cladding surrounds the core. Core is inner part. Cladding covers that particular core. Refractive index of cladding is less than that of core. Conversely, we can say refractive index of core is more than that of cladding. That's why in spite of all those losses, due to total internal reflection, light radiations will traveling from one end towards the other end. Total internal reflection takes place when the angle of incidence and angle of refractions is properly adjusted. So this is the condition. To undergo total internal reflection, what are the conditions? The reflective index of core should be greater than that of refraction index of the cladding. And second one is angle of incidence of light radiations and angle of refraction must be properly adjusted. In most of the cases, angle of incidence is more than that of angle of reflection. When light propagates from one media, that is from core into the other media, that is cladding. When light radiation enters into the optical fiber, it first enters to the core possessing high refractive index, and when it reaches to the cladding possessing the low refractive index, a boundary layer which is present between core and cladding that makes a suitable angle of incidence so that light radiations are reflected within the core itself. Again it touches to the lower boundary and again it's internally refracted. Thus we can say the boundary between core and cladding makes the light to reflects internally and propagate along the axis. This principle of operation of optical fiber cable is being used to carry the signal within the optical fiber from one point towards another point. The working principle of optical fiber, just we have explained, it is elaborated in this particular diagram. Look at here. This is the one media, below this. Here is the boundary between the two media. Above that there is one media and below that there is another media. Let me consider this is the boundary. Let me consider this is the core having the high refractive index, whereas this is the cladding that surrounds the core having the refractive index N2. So the refractive index of N1 and refractive index of N2 are so managed that N2 is greater than N1 is greater than that of N2. That means refractive index of core is greater than that of refractive index of cladding. Then what happens? When light radiations enters into the core and when it incident on the boundary between core and that of cladding depends upon angle of incidence. The ray refracted and goes into the cladding. Look at here. If the proper angle is adjusted, then it will reflect within the core only. Look at here. If the angles are not incident angle is not proper, then it will refract. It will bend and goes to cladding. But if angle of incident is properly adjusted, then it will reflect within the core itself. This is what we can call it as total internal reflection. After that, when again it reaches to the boundary and if angle is properly adjusted to this particular core, again it will reflect internally. This phenomena will take place continuously and radiations are propagated within the core from one end towards the another end. Here the angles are going to be represented. Look at here. Here is cladding and here is the core. This in general media 1, media 2 are being represented. Here core, this side and cladding. This is the critical angle. This is the critical angle. If the angle is exactly equal to critical angle, then it will go along the boundary. It will go along the boundary. It will be refracted, it will bend definitely, but it will travel along the boundary itself. And if angle of incidence is less than critical angle, If angle is equal to critical angle, then it will travel along the boundary, bend along the boundary and travel. If angle of incidence is less than angle of critical angle, look it here. If angle of incidence is greater than that of critical angle, here it is represented, then wave internally being instead of refraction, it will internally reflect. Okay, that will happen. Means this is possible provided angle of incidence is greater than that of critical angle. So this is the critical angle it is represented. If angle of incidence is equal to critical angle, then it will travel along the boundary. If the angle of incidence is less than critical angle, it will be refracted. If angle of incidence is greater than critical angle, it will bend internally. Means this is possible. If you adjust the angle of incidence greater than that of critical angle, then total internal reflection it is possible, and due to total internal reflection, only light radiation will travel from transmitter towards the receiver. Dear students, this is the principle that is being used in optical fiber to carry the signal in the form of light radiation from transmitter towards the receiver. To extend our lecture, let us just introduce the applications of optical fiber. Friends, please do remember, optical fibers are used for point-to-point communication. Optical fibers are used in the power plant, especially nuclear power plant. In nuclear power plant, nuclear fission and fusion reactions are taking place. Very high energy is going to be generated. Instead, without using optical fiber, no communication within the instrument it is possible, and therefore in that particular plant, power plant, optical fibers are being used. Friends, nowadays optical fibers are used in telephone subscriber loop. If you are remembering, in the last semester we have studied the telephone communication, and there we have studied the local loop. And nowadays, within the local loop of telephone communication, optical fibers are being used. In telephone exchange, if it is possible for you to visit the telephone exchange, totally you are going to observe that optical fibers are being used in the telephone exchange. Don't forget that optical fiber communication is also used in closed circuit television system, in CC television system. Optical fibers are being used in aircraft. Optical fibers are also used in aircraft control system. Optical fibers are used in sea, that is ship broadcast communication, means broadcast between ship to ship. Optical fibers are being used. Optical fibers are naturally used in computer networking. Optical fibers are also used in television studio transmitter and receiver interconnections. Optical fibers are very secure. That's why those are used in military communication. Dear students, these are some of the applications which are being used as far as the optical fiber communication is being considered. Dear students, I hope this is the proper time to stop for the first lecture, and in the next time we will go for some of the definitions being used in the optical fiber communication. Let us stop as far as first lecture is being considered.